Now I know it's plus 3. You need to be able to find it on a periodic table and know that it's a plus 3. Yes, so it's 3 because it's in group 3. Nitrate, it ends in ATE, so we look it up on the handout. So we look up nitrate. NO3 minus. So how many negative 1s to cancel a positive 3?
Oh.
Because I need 3 of these, is that we need the parentheses. We need 3 nitrates, 3 NO3s. We need 3 negative 1 groups to cancel the positive 3 in the loop. 1 plus 1, group 2 plus 2, group 3 plus 3. Second cadmium plus 2, silver plus 1. I have copper. What's the charge on copper? Or what's the charge on that copper? Copper is not in groups 1, 2, and 3.
So with the first one, the answer is C, correct? Sorry. Yes? Oh.
Yeah. Yes.
Okay, copper.
So what's the charge on copper?
It's not in groups 1, 2, or 3.
But isn't it 2 for the Roman numerals?
That's what the Roman numerals are.
Oh.
That's the only purpose. And it has to be there because if you look it up on the periodic table, we would be clueless. It doesn't help us. So this is a copper 2. Nitrate, well, that's nitrate.
So the ones in groups 1, 2, and 3.
Just stick it in
You
there.
do not need a Roman numeral because group 1, what's the charge on group 1 metals?
1.
How many negative 1s to cancel a positive 2?
2. You make that look so easy, and then when I'm trying to do it, jeez. So
What's the charge on iron?
Fe
3.
3.
Hydroxide, it ends in IDE. Now, most of the time when it ends in IDE, it means a non-metal. Oxide is oxygen, nitrogen is nitrogen, phosphate is phosphorus. This is one of those 5 exceptions. Hydroxide is polyatomic, which means it's here.
So it's OH negative 1. Well,
So hydroxide,
so take 3. So
how
then
many negative 1s?
3.
Cancel a positive 3.
Okay, 10.
What's the charge on tin? And Roman numeral 4, so it's 4.
OH negative
How many negative 1s to cancel a positive 4?
4.
So let's see. 1 is C, 2 is B, 3 is C, and 4 is A. name of Ca?
Calcium?
Fe is
Iron.
Oh, Fe.
that's a group. That's a group. So we will look them up on the handout. So we look up CO3
NO3, no?
and sorry. And NO3 is nitrate. And you just write that down. That's it.
Oh, you don't have to worry about the numbers or anything, except just a, okay.
Well, not
Yeah.
PO4 phosphate.
Let's see.
That's it. We just write phosphate. Give the name of the metal, give the name of the negative ion. Okay, now, do I need a Roman numeral here?
Yes, because it's not part of, well, no, you don't, because it's under one.
Yeah, right. You don't, but not because it's in group 1, it's in group 2.
Two.
So, 1, group 2, group 3, same cadmium, silver, we do not need a Roman numeral. Calcium's in group 2, we do not need a Roman numeral. Remember, the Roman numeral is there to let us know what the charge is. Because calcium's in group 2, we know that it's a +2. Okay, so that's it, calcium nitrate. Do I need a Roman numeral for iron phosphate?
Yes.
So iron is the transition metal. For this,
What's going to restart?
now we need those numbers. Okay, what's the charge on phosphate? So that's a -3. How many phosphates do we have? We
3,
have 1.
1.
Okay, we do not have parentheses, right? So it's just 1. Cancel a -3 with a +3.
What the heck?
And if there was more, you would have to like multiply. How you did it? Divide.
Well, you would 3 divided by however many. Calcium nitrate, go to the next line. Iron 3 phosphate. Mg is so Mg is magnesium, Pb is lead. So if after the metal comes a group, look it up. If after the metal comes a group, look it up. If after the metal comes a group, if it's in parentheses, look up what's in parentheses. So SO3 is sulfite, SO4 is sulfate, PO3 is phosphite. So SO3 is sulfite, IT. SO4 is sulfate, PO4 is a phosphate.
3.
PO3 is phosphite. PO4 is phosphate. We have the PO3.
Okay.
Write the name of the metal, write the name of the negative ion. For magnesium, do we need a Roman numeral? Magnesium is in group 2.
No, okay.
So that's it. Magnesium sulfide, magnesium sulfate. Lead, do we need a Roman numeral?
Yes.
Yes. You have to calculate.
It's hard to do that.
Okay, what's the charge on phosphite?
-1.
How many phosphites do we have?
Oh, 3.
Have 2 phosphites. -3 times 2 is -6. Cancel that with a +6.
Oh, because you have to get the
What is each lead?
2.
That's over. Sulfide, sulfate. Do not do lead 3. Awesome. It's not a lead. Roman numeral is not how many we have, it's a charge. Fe is
Iron.
Va.
Nickel. Barium. How do you know that it's like the negative numbers on top? Just from memorization or? Oh, okay, okay.
You would look them up.
Yeah.
Now, for the name right now, we may or may not need the charge. If we get the Roman numeral, we need to know the charge. If we don't need the Roman numeral, it doesn't matter. But just for practice. So sulfate is SO4 minus. And also, so SO4 minus sulfate. So we're looking for the name. PO3 plus 5. Where is it? Right here. So PO3 is called phosphide and carbonate. CO3 is carbon. So keep in mind that when you're looking it up here, you're looking for the formula, not the charge, because you don't have the charge here.
Yeah.
Okay, so just look up SO4, PO3, CO3.
But you only really need to do that like for the formula, right? If you need a Roman numeral?
So now that we know what the name is, just write the name. So, A. Okay, now we need to find out if we need the Roman numeral. So for iron, do we need a Roman numeral? Yes. For barium, barium's in group 2. Do we need a Roman numeral?
No.
So we're done. That's it. For nickel, do we need a Roman numeral?
Yes.
Nickel's a transition metal. Okay. What's the charge on sulfate?
Negative. So then you have to balance it.
So it's -2. How many do we have?
3.
It's a total of -6. Cancel that with a +6. 6 divided by 2.
3. Okay.
Plus carbonate. What's the charge on carbonate?
-2.
How many carbonates do we have? 1. We only have one CO3. That in parentheses.
Oh, okay.
So to cancel a -2, you need a +2.
Why don't you just put that in there? Very.
Sulfate plus light. 2. Carbon. Now remember, all of these are ionic compounds. All of these begin with a metal or ammonia. So we're here. Okay, there's still this section that we need to cover. Okay, so all of these rules are for this.
No.
So, does it begin with a metal or ammonia? And the answer is yes, it's ionic. Then you have a positive part and a negative part. That positive part is pure metal or ammonia. If it's a metal, then it only forms one positive ion, it's monovalent. Group 1, group 2, group 3, zinc, cadmium, and silver. This can form more than one positive ion. And these are the ones that need a Roman numeral. The ones that are not in groups 1, 2, and 3, zinc, cadmium, and silver. So that's the positive side. On the negative side, then either it can be monatomic, which means it's a non-metal. The ending of that non-metal is changed to IBE. Fluoride becomes fluoride, oxygen becomes oxide, sulfur becomes sulfite, so on and so forth. If it's a group, it's polyatomic, use the handout, use the table. The table tells you the name, the formula, and the charge. Almost all polyatomic ions end in 8 or 8, except for those 5. Acide, cyanide, hydroxide, peroxide, and thiocyanide. Those end in IPE. So name the metal, name the negative ion, IDE, AT, IT. Those are your only 3 choices. And then check to see if you need the Roman numeral. If it's in groups 1, 2, or 3, zinc, cadmium, or silver, you don't need the Roman numeral. If it's not in those, then you have to calculate the Roman numeral. You cannot look it up. It has to be calculated from the formula that you're given. If you have the name and need to come up with a formula, then you have to balance and put subscripts if you need to get to 0. Okay, if you have a polyatomic ion and you only need 1, do not put it in parentheses. But if you need to have 2 or more, then put it in parentheses and then put how many you need on the other side. Okay, leave it here, and then we'll do, the other part is easier.
Okay.
And actually we'll cover this tomorrow night. This takes like 10 minutes.
Yay.